Hello, in this lecture we'll find out the values of line segments X and Y. In the drawing we have square DEBF, and the square is inside the right triangle ABC. We also know that DB equals to BF equals to 1, DB equals to 1 unit, BF equals to 1 unit, and because of the fact that all the sides of a square are equal to each other, EF will also be equal to 1 unit and DE will also be equal to 1 unit. And we know also that the hypotenuse AC of the right triangle ABC equals to 3 units. And we want to find out the value of line segment FC that is actually equals to X, and the value of line segment AD that equals to Y. Okay? So first of all, we have the rule that the opposite sides of a square are parallel to each other. That is to say, DE is parallel to BF, so I write it down. We know that DE is parallel to BF. And we also know that BC is one side BC is one side of the right triangle ABC. So BC, it is absolutely a straight line. BC is a straight line. It's a side of a right triangle. It must be a straight line. And we also know that BF is part of the straight line BC, and BF is parallel to DE. So if part of the straight line BC is parallel to DE, then the straight line BC itself will be also parallel to DE. Okay, we can write down that BC parallel to DE. BC is parallel to DE because of the fact that if part of a straight line is parallel to another straight line, then the straight line itself will be also parallel to that straight line. And we know that part of the straight line, that is BF, is parallel to DE, therefore the straight line itself BC will be also parallel to DE. And we have also rule number 1. According to rule number 1, corresponding angles between parallel lines are equal to each other. I will read rule number 1 again. According to rule number 1, corresponding angles between parallel lines are equal to each other, and in our drawing, we have those two angles are defined as corresponding angles, and they are located between the parallel lines DE and BC, therefore they are equal to each other. So angle AED is equal to angle ECF. According to rule number 1, I write it down. Angle AED is equal to angle ECF I'll repeat again. Angle AED equals to angle ECF according to rule number 1, because of the fact that those two angles are defined as corresponding angles and are located between the parallel lines DE and BC, they are equal to each other. So if we define angle AED as theta, angle AED equals to theta, then from this equation, theta equals to angle AED equals to angle ECF, we will derive that angle ECF also equals to theta. Angle ECF also equals to theta. Now this angle ECF equals to theta. In the next step I will present to you a new rule, rule number 2. According to rule number 2, the sum of the angles on one side of a straight line are equal to 180 degrees. I write it down. The sum of the angles on one side of a straight line is equal to 180 degrees. We will read rule number 1 again, rule number 2 again. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. In our drawing, we know that AB is one side of the right triangle, triangle ABC, therefore AB, it is absolutely a straight line. So I write down that AB is a straight line. So if we focus on this side of the straight line AB at point D, then angle AED that we will define as angle X plus this angle that equals to 90 degrees. In total, the sum of those two angles, they must be equal to 180 degrees according to rule number 2. So I'll write it down. angle x plus 90 degrees must be equal to 180 degrees according to rule number 2. Here we subtract 90 degrees from this equation and we get that angle x equals to 180 degrees minus 90 degrees is 90 degrees. So we found out that angle x is a right angle. It equals to 90 degrees. So I will substitute angle x by a right angle. So actually, because of the fact that angle ADE is a right angle, therefore triangle ADE is a right triangle. Likewise, BC is one side of the right triangle, triangle ABC. Therefore, it is absolutely a straight line. BC is a straight line. And if we focus on the upper side of the straight line BC at point F, then the sum of the angles at point F must be equal to 180 degrees according to rule number 2. So if we define angle EFC as angle Y, then angle Y plus this angle that is equal to 90 degrees, in total they must be equal to 180 degrees according to rule number 2. So here we will subtract 90 degrees from this equation and we get that angle Y equals to 180 degrees minus 90 degrees is 90 degrees. So we found out that angle Y is a right angle, that is to say it equals to 90 degrees. So I will substitute angle Y by a right angle. And because of the fact that angle EFC is a right angle, therefore triangle EFC is a right triangle. In the next step, we will focus on the right triangle, triangle AED. On the right triangle, triangle AED. We know that tangent theta equals to AD over DE. I will repeat again, in the right triangle, triangle AED, tangent theta equals to AD over DE. AD equals to Y according to what is given us in the question, and DE equals to 1 unit. So in conclusion, we found out that according to equation number 1, tangent theta equals to Y. in the next step we will focus on the right triangle, triangle EFC, this right triangle. On the right triangle, triangle EFC. Tangent theta will be equal to EF over FC. I repeat again, in the right triangle, triangle EFC, we know that tangent theta equals to EF over FC. EF equals to 1 unit, and FC equals to X. So in conclusion, we found out that according to equation number 2, tangent theta equals to 1 over X. In the next step, we will create equation number 3 that states that tangent theta according to equation number 1 must be equal to tangent theta according to equation number 2. So according to equation number 3, tangent theta according to equation number 1 is y, and it must be equal to tangent theta according to equation number 3, that is actually 1 over x. So in conclusion, we found out that according to equation number 3, y equals to 1 over x. What does equation number 3 mean? It means that y is the inverse number of x. And if you multiply equation number 3 by x and then we divide it by y, we get that x equals to 1 over y. Therefore, x is also the inverse number of y. So here, if we multiply equation number 3 by x, we get that x times y equals to 1. So whenever the multiplication of two numbers gives us 1, whenever the result is 1, then we know that each of the numbers is the inverse number of the other number. So here we can write down that x is the inverse number of y, and it is also true to say that y is the inverse number of x. And it is also very important to emphasize that every number has only one inverse number. Okay? I will write it down. The rule, every number has only one inverse number. That is to say, for example, 1 over 5 is the inverse number of 5, and 5 is the inverse number of 1 over 5, and the only inverse number of 5 is 1 over 5, and the only inverse number of 1 over 5 is 5. Okay? So in the next step we will focus on the right triangle, triangle ABC. On the right triangle, triangle ABC. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse on the right triangle, triangle ABC is AC. Therefore, the square of the hypotenuse is AC squared. And it equals to the sum of the squares of the perpendiculars. That is to say, it equals to AB squared plus BC squared. I'll repeat again. In the right triangle, triangle ABC, according to the Pythagoras theorem, P, the letters P and T is the abbreviation for Pythagoras theorem. So according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AC squared equals to AB squared plus BC squared. So according to equation number 4, we get that AC squared, AC is 3 units, so AC squared is 3 squared. 3 squared is 9. And it equals to AB squared. AB is 1 plus y, so AB squared is y plus 1 squared. Plus BC squared. BC equals to x plus 1, so BC squared equals to x plus 1 squared. So, in conclusion, we found out that according to equation number 4, 9 equals to y plus 1 squared plus x plus 1 squared. Here, we will open the brackets on both sides, on this side of equation number 4, and we will get that according to equation number 4, y plus 1 squared equals to y squared plus 2y plus 1, and x plus 1 squared equals to x squared plus 2x plus 1, and it equals to 9. According to equation number 3, we found out that y equals to 1 over x. Therefore, we can substitute y in equation number 4 by 1 over x, we'll do it now, and we will get that according to equation number 4, y squared will be equal to 1 over x squared plus 2y. Y is 1 over x, so it is plus 2 times 1 over x plus 1 plus x squared plus 2 equals to 9. One plus 1 is 2, so I write it down. X squared plus 1 over x squared plus 2 plus 2 over x equals to 9. Here we have y squared plus 2y plus y equals to x squared plus 2x plus 1. So here we have also to add 2x. It is actually plus 2x equals to 9. So it is here we will have 2x and 2 over x plus 2x so the expression inside the brackets equals to x plus 1 over x squared and here we take 2 as a common factor out of these two expressions, and we'll get inside the brackets we will have x plus 1 over x equals to 9. We will define t as x plus 1 over x, that is to say t is equal to x plus 1 over x according to our definition. So here we can substitute x plus 1 over x in equation number 4 by t. We will do it now. We will get that x plus 1 over x squared is t squared plus 2 times x plus 1 over x is 2t. Here we subtract 9 from equation number 4, so it will be minus 9 equals to 0. So we got here a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for, and we will find out the value of x according to a special formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. Okay, so in our specific expression, in our specific quadratic equation, we know that t squared minus 2t minus 9 equals to 0. Here the variable that we are looking for is t, so x equals to t. The coefficients of this quadratic equation is as follows: a equals to 1, b equals to minus 2, and c is actually t squared plus 2t. Here it is plus 2t, so b equals to plus 2 and c equals to minus 9. So we will put the data inside the formula for x, and we will get that x that equals to t equals to minus b. B is 2, so minus b is minus 2 plus minus square root of b squared. B is 2, so b squared is 2 squared. 2 squared is 4 minus 4 times a times c. A is 1, so minus 4 times 1 is minus 4 times c is 9, so it is minus 4 times minus 9 over 2a. A is 1, so 2 times 1 is 2. So we got here that t equals to minus 2 plus minus. Inside the root we have 4, and minus 4 times minus 9 is plus 36. 4 plus 36 is 40, all divided by 2. So t equals to minus 2 plus minus. We know that 40 is actually 4 times 10, and the square root of 4 is 2, so we'll get here that 40 is 2 times square root of 10 over 2. So minus 2 over 2 is minus 1. So t equals to minus 1 plus minus 2 over 2 is 1. So we left with only square root of 10. So we have here two possible solutions for t. The first solution for t is t equals to minus 1 plus square root of 10. And the second solution for t is t equals to minus 1 minus square root of 10. T is equal to x plus 1 over x according to our definition. And here we got that t equals to minus 1 minus square root of 10 . So x is length. X is length, and length is a positive number. If x is a positive number, then x plus 1 over x will be also a positive number. And according to this solution, we get that x plus 1 over x, that is a positive number, equals to minus 1 minus square root of 10, that is a negative number. And because of the fact that a positive number can never be equal to a negative number, we got a contradiction. Therefore, this solution is incorrect solution. We will cancel this solution, and we left only with the solution that t equals to minus 1 plus square root of 10. According to our definition, t equals to x plus 1 over x, and it equals to minus 1 plus square root of 10. Here we will multiply x by x, and then we will divide it by x in order to have a common factor with 1 over x, and we will get that x squared plus 1 over x equals to square root of 10 minus 1. Here we will multiply this equation by x, and we will get that x squared plus 1 equals to square root of 10 minus 1 times x. So here we will subtract from this equation square root of 10 minus 1 times x, and we will get a quadratic equation. According to this quadratic equation, we have x squared minus square root of 10 minus 1 times x plus 1 equals to 0. In this quadratic equation, we know that the coefficient a equals to 1, the coefficient b equals to minus square root of 10 minus 1, and the coefficient c equals to 1, and the solution for a quadratic equation is x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a So we have all the data that we need to find out the value of x in this specific quadratic equation. We will put the data inside the formula for x, and we will find out the value of x in this quadratic equation. So we get that x equals to minus b, b equals to minus square root of 10 minus 1. Minus b will be equal to minus square root of 10 minus 1. Minus is plus. So in conclusion, we found out that minus b equals to square root of 10 minus 1 plus minus square root of b squared. Square root of b squared is square root of 10 minus 1 squared. And minus 4 times a times c. A equals to 1, c equals to 1. Therefore, minus 4 times a times c will be equal to minus 4, all divided by 2. Actually, 2 times a is 2 times 1, and 2 times 1 is 2. So x will be equal to square root of 10 minus 1 plus minus here we have square root of 10 minus 1 square. We will calculate the value of this expression according to algebraic identity that states that a minus b squared equals to a squared plus b squared minus 2 times ab. So a is square root of 10 and a squared is square root of 10 squared, that is actually 10 plus b squared is 1 square is 1 minus 2 times a is square root of 10 minus 4 all divided by 2. Okay? So here we have inside the root 10 plus 1 is 11, 11 minus 4 is 7. So I will write it down. We got that x equals to square root of 10 minus 1 plus minus. So we got here 7 minus 2 times square root of 10 all divided by 2. So we will calculate the value of the expression inside the root, that is actually 7 minus square root of 10, or in other words, we will present this expression in another form. So the expression inside the root is 7 minus 2 times square root of 10 and 7 minus 2 times square root of 10, actually it equals, first of all, 7 is 5 plus 2, so we will substitute 7 by 5 plus 2 minus 2, and the square root of 10 is square root of 5 times square root of 2, so we will substitute square root of 10 by square root of 5 times square root of 2. Five is equal to square root of 5 square, and 2 is equal to square root of 2 square, minus 2 times square root of 5 times square root of 2. Actually, the expression square root of 5 square plus square root of 2 square minus 2 times square root of 5 times square root of 2 is very similar to the algebraic identity that states that a squared plus b squared minus 2 times ab equals to a minus b squared. That is to say, we can substitute this expression by a minus b squared when a is equal to square root of 5 and b equals to square root of 2. So we'll do it now, and we'll get that square root of 5 minus square root of 2 square is equal to this expression. In conclusion, we actually found out that the expression 7 minus 2 times of square root of 10 equals to square root of 5 minus square root of 2 squared. That is to say, we can substitute the expression, this expression 7 minus 2 times square root of 10 by this expression that is square root of 5 minus square root of 2 squared. So we'll do it now, and we will get that x equals to square root of 10 minus 1 plus minus so inside the root we have the expression of 7 minus 2 times square root of 10, and as I already said, we'll substitute this expression by square root of 5 minus square root of 2 squared. All divided by 2. So x equals to square root of 10 minus 1 plus minus here we have square and root, so the square cancels the root and we left only with square root of 5 minus square root of 2 all divided by 2. So we have here two solutions that are possible for x. We will define the first solution as x1 and the second solution as x2. So the first solution, x1 equals to square root of 10 minus 1 plus square root of 5 minus square root of 2 all divided by 2. So I will copy the first solution here. x1 equals to square root of 10 minus 1 plus square root of 5 minus square root of 2 all divided by 2. And the second solution is x2. x2 will be equal to square root of 10 minus 1 minus square root of 5 minus square root of 2 all divided by 2. So we'll continue here with x1, and we will get that x1 equals to, here we have square root of 10, so we'll substitute square root of 10 by square root of 5 times square root of 2, minus 1 plus square root of 5 minus square root of 2 all divided by 2. Here we will take square root of 5 as a common factor, and we get that x1 equals to square root of 5 is taken as a common factor. Inside the brackets we will have square root of 2 plus 1, and here we will take minus 1 as a common factor out of these two expressions, and inside the brackets we will have here square root of 2 plus 1 all divided by 2. So here we will take square root of 2 plus 1 as a common factor out of this expression, and we will get that x1 equals to square root of 2 plus 1 is taken as a common factor, and inside the brackets we will have square root of 5 minus 1 all divided by 2. So in conclusion, we found out that x1 equals to square root of 2 plus 1 times square root of 5 minus 1 all divided by 2. We will repeat on the same process for x2, and we get that x2 equals to square root of 10 minus 1 minus square root of 5, and here we have minus, and minus is plus, square root of 2 over 2. So x2 equals to, we'll substitute square root of 10 by square root of 5 times square root of 2. Here we take square root of 5 as a common factor, and we get that here square root of 5 is taken as a common factor. Inside the brackets we'll have here square root of 2 minus 1 plus square root of 2 minus 1 all divided by 2. So here we take square root of 2 minus 1 as a common factor out of this expression, and we get that x2 equals to square root of 2 minus 1 is taken as a common factor, and inside the brackets we will have square root of 5 plus 1 all divided by 2. So in conclusion, we found out that x2 equals to square root of 2 minus 1 times square root of 5 plus 1 over 2, and x1 equals to square root of 2 plus 1 times square root of 5 minus 1 over 2. In the next step, we'll multiply x1 by x2, and we'll get that. So here I will copy x1 and x2 in a new page. We actually found out that x1 equals to square root of 2 plus 1 times square root of 5 minus 1 all divided by 2. And we also found out that x2 equals to square root of 2 minus 1 times square root of 5 plus 1 all divided by 2. In the next step we will multiply x1 by x2 and we will get that x1 is equal to square root of 2 plus 1 times square root of 5 minus 1 all divided by 2 times x2, that is actually square root of 2 minus 1 times square root of 5 plus 1 all divided by 2. So here we will organize the expressions of x1 times x2 in a different order, and we will get that x1 times x2 equals to square root of 2 plus 1 times square root of 2 minus 1 times square root of 5 plus 1 times square root of 5 minus 1 all divided by 2 times 2. So the expression square root of 2 plus 1 times square root of 2 minus 1 is very similar to the algebraic identity that states that a plus b times a minus b equals to a squared minus b squared. In our specific expression, square root of 2 plus 1 times square root of 2 minus 1, a equals to square root of 2 and b equals to 1. So we get that this expression equals to a squared minus b squared. A is square root of 2. A squared is square root of 2 squared. Square root of 2 squared is 2 minus b squared. B is 1. B squared is 1 squared. 1 squared is 1. So minus b squared is minus 1. So in conclusion, we found out that square root of 2 plus 1 times square root of 2 minus 1 equals to 2 minus 1. We will calculate the value of the expression square root of 5 plus 1 times square root of 5 minus 1. In the same way, here we know that a equals to square root of 5 and b equals to 1. So this expression equals to a squared minus b squared according to this algebraic identity. A equals to square root of 5. So a squared is square root of 5 squared, that is 5. Minus b squared. B is 1, so b squared is 1 squared. 1 squared is 1, so minus b squared is minus 1. So in conclusion, we found out that square root of 2 plus 1 times square root of 2 minus 1 equals to 2 minus 1. And square root of 5 plus 1 times square root of 5 minus 1 equals to 5 minus 1. All divided by 2 times 2, that is 4. So here 2 minus 1 is 1. 5 minus 1 is 4 over 4. 1 times 4 is 4, and 4 over 4 is 1. So we actually found out that x1 times x2 equals to 1. I'll repeat again. We found out that x1 times x2 equals to 1. What does it mean? It means that x1 is the inverse number of x2. And we also found out that x2 is the inverse number of x1. Okay? And according to equation number 3, we have already found out that x times y equals to 1. So according to equation number 3, x times y equals to 1. It also means that x is the inverse number of y and y is the inverse number of x. But if we put the solutions that we found for x and y inside this equation number 3, so the first solution is x1, y1, and if we substitute x by x1 and y by y1, we will get that x1 times y1 equals to 1. what does this equation means? It means that y1 is the inverse number of x1. Okay, y1 is the inverse number of x1, but according to what we already found out, we have already found out that x2 is the inverse number of x1. And according to the rule that I mentioned in the beginning of the lecture, the rule is that every number has only one inverse number. That is to say, x1 has only one inverse number. So if x1 has only one inverse numbers, it means that y1 must be equal to x2. Okay? Otherwise, we will get that x1 has two different inverse numbers, and because of the fact that x1 has only one inverse numbers, we must conclude that x1 equals to x2. And likewise, we have equation number 3 states that x times y equals to 1. We will put the solution, the second solution, x2 and y2 inside equation number 3, and we will get that x2 times y2 equals to 1. What does it mean? It means that y2 is the inverse number So, according to equation number 3, that x2 times y2 equals to 1, we conclude that y2 is the inverse number of x2. But we have already found out that x1 is the inverse number of x2. But we know that x2 can have only one inverse number. Therefore, if we have two numbers that are the inverse number of x2, we will conclude that they are equal to each other. That is to say, y2 equals to x1. In conclusion, we found out that y1 is equal to x2 and y2 is equal to x1. Now we will write down the solution to the question. The first solution is x1 y1, and we have already found out that x1 equals to square root of 2 plus 1 times square root of 5 minus 1 over 2. This is x1, and y1 according to what we have already found out, y1 equals to x2. That is to say, it equals to square root of 2 minus 1 times square root of 5 plus 1 over 2. This is the first solution to the question, and the second solution is x2 y2, and x2 equals to square root of 2 minus 1 times square root of 5 plus 1 over 2. This is x2, and we have already found out that y2 equals to x1. That is to say, y2 equals to square root of 2 plus 1 times square root of 5 minus 1 over 2. Okay, so those are the two solutions to the question. Now I will summarize the lecture. Actually, we wanted to find out the values of line segment X, that is FC equals to S, and line segment AD that equals to Y. And we have square DEBF. One side of this square equals to 1 unit, and this square is located inside the right triangle ABC. We know that the hypotenuse of the right triangle ABC equals to 1 unit. The hypotenuse AC equals to 3 units, and we want to find out the value of line segment X and Y. So first of all, we have the rule that the opposite sides of a square are parallel to each other. That is to say, DE is parallel to BF, DE is parallel to BF, and BC is one side of BC is one side of the right triangle ABC, and therefore BC must be a straight line. Okay, BC is a straight line, but we know that BF, that is part of the straight line BC, is parallel to DE. So if the part of the straight line BC is parallel to DE, then the straight line itself BC will be parallel to DE. Okay, so BC is parallel to DE. And we have rule number 1 that says that corresponding angles between parallel lines are equal to each other. Those two angles are defined as corresponding angles, and they are located between the parallel lines DE and BC. That is to say, DE is parallel to BC. Therefore, they are equal to each other according to rule number 1. Okay, so angle AED equals to angle ECF according to rule number 1. And if we define angle AED as theta, here angle AED equals to theta, from this equation we will derive that angle EFC also equals to theta. Here this angle also equals to theta, so we found out that those two angles, they are equal to each other, they are both equal to theta. Then I presented to you rule number 2. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. And here we know that AB is one side of the right triangle, triangle ABC, therefore it is absolutely a straight line. Okay, AB is a straight line, and if we focus on this side of the straight line AB at point D, then according to rule number 2, the sum of the angles at point D on this side of the straight line AB must be equal to 180 degrees. So if this angle is angle X plus this angle that is equal to 90 degrees, the sum of those two angles must be equal to 180 degrees according to rule number 2. Angle X plus 90 degrees must be equal to 180 degrees according to rule number 2. We subtracted 90 degrees from this equation and we found out that angle X equals to 180 degrees minus 90 degrees, that is to say angle X equals to 90 degrees. So this angle is a right angle, therefore triangle ADE is a right triangle. And likewise, BC is one side of the right triangle, triangle ABC, therefore it is absolutely a straight line. BC is a straight line, and according to rule number 2, if we focus on the upper side of the straight line BC at point F, then the sum of the angles here must be equal to 180 degrees. So this angle that equals to 90 degrees, plus this angle that we defined as angle Y, in total the sum of those two angles must be equal to 180 degrees. So Y plus 90 degrees must be equal to 180 degrees. We subtracted 90 degrees from this equation, and we found out that 180 degrees minus 90 degrees equals to 90 degrees. So we found out that angle Y is a right angle, therefore triangle EFC is a right triangle. Then we focus on the right triangle, triangle AED. In this right triangle, we know that triangle theta equals to AD over DE. According to equation number 1, in the right triangle, triangle AED, triangle theta equals to AD over DE. AD equals to Y according to what is given in the equation. D equals to 1. So in conclusion, we found out that triangle theta according to equation number 1 equals to Y. Then we focus on the right triangle, triangle EFC. On the right triangle, triangle EFC, we know that triangle theta equals to EF over FC. Again, in the right triangle, triangle EFC, we know that triangle theta equals to EF over FC. Here, EF equals to 1, FC equals to X. In conclusion, we found out that triangle theta, according to equation number 2, equals to 1 over X. Then we created equation number 3 that states that tangent theta according to equation number 1 must be equal to tangent theta according to equation number 2. That is to say, according to equation number 3, tangent theta according to equation number 1, that is Y, must be equal to tangent theta according to equation number 2, that is 1 over X. In conclusion, we found out that according to equation number 3, Y equals to 1 over X. It means that Y is the inverse number of X, and also X is the inverse number of Y. We multiply the equation number 3 by X, and we got that XY equals to X. Again, when you have two numbers that the multiplication between them is 1, it means that 1 is the inverse number of the other. So we can write down that X is the inverse number of Y, and Y is the inverse number of X. And we have also another rule. The rule states that every number has only one inverse number. Okay, 5, the inverse number of 5 is 1 over 5. It is only 1 over 5. And the inverse number of 1 over 5 is 5. And it is only 5, there is no another number that is the inverse number of 1 over 5. Then we focused on triangle ABC, the right triangle, according to the Pythagoras theorem. PT is the Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say AC squared equals to AB squared plus BC squared. Again, AC squared equals to AB squared plus BC squared. AC equals to 3, so AC squared is 3 squared. 3 squared is 9. AB is y plus 1. AB square is y plus 1 square plus BC square. BC is 1 plus x, or x plus 1. BC square is x plus 1 square. In conclusion, we found out that according to equation number 4, 9 equals to y plus 1 square plus x plus 1 square. Here, we open the brackets on this side of equation number 4, and we got that y plus 1 square is y square plus 2y plus 1, and x plus 1 square is x square plus 2x plus 1, and on the other side of the equation we have 9, so it equals to 9. Here, according to equation number 3, we know that y is equal to 1 over x. So what does it mean? It means that we can substitute y in equation number 4 by 1 over x. We did it, and we got that y square is 1 over x square, plus 2y is plus 2 1 over x, plus 1 equals to x square plus 2x plus 1. And here, and we organized the expressions of equation number 4 in another order, and we got that x squared plus 1 over x squared plus 2 over x plus 2x equals to 9. The expression inside the brackets equals to x plus 1 over x squared. And here we took 2 as a common factor of those two expressions. And inside the brackets we have x plus 1 over x, and they are equal to 9. And here we defined t as x plus 1 over x, that is to say t equals to x plus 1 over x according to our definition. And what does it mean? It means that we can substitute x plus 1 over x in equation number 4 by t. We did it, and we got that here we have t squared plus 2t minus 9 equals to 0. So this is a quadratic equation. And the general formula for a quadratic equation is actually ax squared plus bx plus c equals to 0. Here a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for, and we will find out the value of x according to a special formula for x. The special formula for x is x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, t squared plus 2t minus 9 equals to 0, the coefficients are as follows. The variable that we are looking for is t, so x equals to t, a equals to 1, b equals to 2, and c equals to minus 9. So the only thing that is left to do is to put the data that we have for our specific quadratic equation inside the formula for x, and we will find out the value of t that equals to x. So we did it, and we got that t equals to minus b. B equals to 2, so minus b is minus 2, plus minus square root of b squared. B equals to 2, b squared is 2 squared, 2 squared is 4, minus 4 times ac. A equals to 1, c equals to minus 9, so it is minus 4 times minus 9. And then we have t equals to minus 2 plus minus. Minus 4 times minus 9 is 36, and 36 plus 4 is 40. So in conclusion, we got that t equals to minus 2 plus minus square root of 40 over 2. 40 is 4 times 10. Square root of 4 is 2. So in conclusion, we got that t equals to minus 2 plus minus 2 times square root of 10 over 2. So here we have two solutions that are possible for t. The first solution is t equals to 1 plus square root of 10, and the second solution for t is 2 equals to minus 1 minus square root of 10. And this solution, first of all, what the value of t according to our definition is x plus 1 over x. And x is length. It is the length of the right triangle, the length of one side of triangle EFC. Therefore, it must be a positive number. So if x is positive, then x plus 1 over x is also a positive number. So on this side of the equation, we have a positive number. And in the other side of the equation, we have minus 1 minus square root of 10. That is a negative number, and a positive number can never be equal to a negative number. Therefore, we got a contradiction. That is to say, this solution is incorrect solution, so we cancel this solution, and we left only with the solution that t equals to minus 1 plus square root of 10. T, according to our definition, is equal to x plus 1 over x. And it equals to minus 1 plus square root of 10. Here we multiplied x by x, and then we divided by x in order to have a common factor with 1 over x. And we got that x squared plus 1 over x equals to square root of 10 minus 1. Here we multiplied this equation by x, and we got that x squared plus 1 equals to square root of 10 minus 1 times x. Here we subtracted minus square root of 10 minus 1 times x from this equation, and we got here a quadratic equation. The quadratic equation that we got is x squared minus square root of 10 minus 1 times x minus 1 plus 1 equals to 0. In our specific quadratic equation, the coefficients are as follows: a equals to 1, b equals to minus square root of 10 minus 1, and c equals to 1. And the general formula for the solution for a quadratic equation is x equals to minus b plus minus square root of b squared minus 4 times ac over 2a, and x equals to minus b, and b equals to minus square root of 10 minus 1, so minus and minus is plus, and in conclusion, I found out that minus b equals to square root of 10 minus 1 plus minus b squared. B squared is square root of 10 minus 1 squared minus 4 times ac. A is 1, c is 1, so minus 4 times ac is minus 4, all divided by 2. So we got that x equals to square root of 10 minus 1 plus minus square root of 10 minus 1 squared. We did it according to the algebraic identity that a minus b squared equals to a squared plus b squared minus 2 times ab. So it will be a squared is minus square root of 10 squared is 10, plus b squared is plus 1 squared, it is 1, minus 2 times square root of 10 minus 4 over 2. So x equals to square root of 10 minus 1 plus minus. Here inside the root we have 10 plus 1 is 11, 11 minus 4 is 7. So inside the root we have 7 minus 2 times square root of 10. And we presented the expression inside the root that is 7 minus 2 times square root of 10 in a different way, in a different form. Here 7 minus 2 times square root of 10 equals to 5 plus 2. We substitute the 7 by 5 plus 2, and we have also 2 times square root of 10. We substituted square root of 10 by square root of 5 times square root of 2, and we got here, we know that 5 is square root of 5 square and 2 is square root of 2 square. So in conclusion, we found out that 7 minus 2 times square root of 10 equals to square root of 5 plus square root of 5 square plus square root of 2 square minus 2 times square root of 5 times square root of 2. And this expression is very similar to the expression, to the algebraic identity that a squared plus b squared minus 2 times ab equals to a minus b squared. That is to say, we can substitute this expression by a minus b squared when a equals to square root of 5 and b equals to square root of 2. We did it, and we got that this expression equals to square root of 5 minus square root of 2 squared. So in conclusion, we found out that the value of 7 minus 2 times square root of 10 equals to square root of 5 minus square root of 2 squared. Therefore, we can substitute this expression that is inside the root by this expression. We did it, and we got that x equals to square root of 10 minus 1 plus minus. So we substituted 7 minus 2 times square root of 10 by square root of 5 minus square root of 2 squared, all divided by 2. So we got that x equals to square root of 10 minus 1 plus minus. Here we have, inside the root we have square and root. The square cancels the root, and we left only with square root of 5 minus square root of 2 over 2. Okay, so in conclusion, we found out that x equals to square root of 2 minus 1 plus minus square root of 5 minus square root of 2 over 2. And here, so x, we have here two solutions that are possible for x. The first solution, we defined it as x1, and it is equal to, the first solution is the square root of 10 minus 1 plus the square root of 5 minus 2 over 2. This is the first solution, x1. And the second solution for x is square root of 10 minus 1 minus square root of 5 minus 2 minus square root of 2 over 2. So we have here two solutions for x, x1 and x2. We developed the first solution. Here we substituted square root of 10 by square root of 5 times square root of 2, and we got that x1 equals to square root of 5 times square root of 2 minus 1 plus square root of 5 minus square root of 2 over 2. Here we took square root of 5 as a common factor out of this expression, and inside the brackets we have square root of 2 plus 1 minus square root of 2 plus 1. Here we took square root of 2 plus 1 as a common factor, and inside the brackets we have square root of 5 minus 1, all divided by 2. So in conclusion, we found out that x1 equals to square root of 2 plus 1 over square root of 5 minus 1 over 2. Then we developed the second solution, x2, and so we got here that x2 equals to square root of 10 minus 1 minus square root of 5, and minus is plus, so it is plus square root of 2 over 2. Here we substituted square root of 10 by square root of 5 times square root of 2, and we got that x2 equals to square root of 5 times square root of 2 minus 1 minus square root of 5 plus square root of 2 over 2. Here we took square root of 5 as a common factor out of this expression, and inside the brackets we have square root of 2 minus 1 plus square root of 2 minus 1 over 2. We took square root of 2 minus 1 as a common factor out of this expression, and we found out that x2 equals to square root of 2 minus 1 times square root of 5 plus 1 over 2. So we got the values of x1 and x2. I copied the values of x1 and x2 in this page. This is x1, this is x2. Then we multiplied x1 by x2. We got this expression, and then I organized the expressions of x1 times x2 in a different order, and we found out that x1 times x2 equals to square root of 2 plus 1 times square root of 2 minus 1 times square root of 5 plus 1 times square root of 5 minus 1 over 2 times 2. Here we calculated the value of the expression of square root of 2 plus 1 times square root of 2 minus 1 according to the algebraic identity that states that a plus b times a minus b equals to a squared minus b squared. In our specific expression, a is equal to square root of 2 and b equals to 1. So we know that the result of this multiplication must be equal to a squared minus b squared. A squared, when a is square root of 2, a squared is square root of 2 squared is 2. Minus b squared, b is 1. B squared is 1 squared is 1. So minus b squared is minus 1. So in conclusion, we found out that the result of the multiplication of this expression equals to 2 minus 1. That is actually 1. And then we multiplied square root of 5 plus 1 by square root of 5 minus 1. And we found the value of this multiplication according to the algebraic identity. It must be equal to a squared minus b squared. In our specific expression, a is square root of 5, b is 1. So a squared is square root of 5 squared. Square root of 5 squared is 5. Minus b squared, b is 1. B squared is 1 squared, 1 squared is 1. So in conclusion, we found out that square root of 5 plus 1 times square root of 5 minus 1 equals to 5 minus 1. So x1 times x2 equals to 2 minus 1 times 5 minus 1. According to what we have already found out, it is 2 minus 1 times 5 minus 1 over 2 times 2, that is 4. 2 minus 1 is 1, 5 minus 1 is 4, all divided by 4. 4 times 1 is 4, 4 over 4 is 1. So we found out that x1 times x2 equals to 1. Okay? We found out that x1 times x2 equals to 1. What does it mean? It means that x1 is the inverse number of x2, and also x2 is the inverse number of x1. But according to equation number 3, we have already found out that x times y equals to 1. The first solution to our quadratic equation was x1, and the second solution was x2. So the first solution for x is x1, for y is y1, so we put the solution inside equation number 3. That is to say, x equals to x1 and y equals to y1, and we found out that x1 times y1 equals to 1. What does it mean? It means that y1 is the inverse number of x1. Okay? But we have already found out that x1 is the inverse, we have already found out that x2 is the inverse number of x1. Okay? So, but we have the rule that every number has only one inverse number. So if we have two numbers that are the inverse number of another number, they must be equal to each other. That is to say, y1 equals to x2. Then we repeat on the same process for the second solution. the second solution is x, for x is x2 and for y is y2. We put the solution inside the equation number 3. X equals to x2 and y equals to y2. And we got that x2 times y2 equals to 1. What does this solution mean? It means that y2 is the inverse number of x2. But we have already found out that x1 is the inverse number of x2. And every number has only one inverse number. x2 has only one inverse number. So if we have two numbers that are the inverse number of x2, it means that they must be equal to each other. That is to say, y2 equals to x1. And we have already found out that y1 equals to x2. And then I presented the solution to the question. The solution is actually x1 is square root of 2 plus 1 times square root of 5 minus 1 over 2. And y1, we already found out that y1 equals to x2. Okay, this is y1 that equals to x2, that is actually square root of 2 minus 1 times square root of 5 plus 1 over 2. And then the second solution to the problem is x2 and y2. x2 equals to square root of 2 minus 1 times square root of 5 plus 1 over 2. And y2, we already found out that y2 equals to x1. That is to say, it equals to square root of 2 plus 1 times square root of 5 minus 1 over 2. So those are the two solutions for x and y. Okay, thank you very much.